Hello students. So in this video we will be discussing some practice questions based on the concepts that we have discovered, that we have studied in the last 3 lectures. That is basic structure of C++, data types in C++, expressions in C++. So in this video we will be solving some of the questions that can give us a practical understanding of the last 3 lectures covered, right? So let us proceed. So the first question is suppose I'm asking you, calculate the area of a circle if radius is given. So I am asking you this question. Calculate the area of a circle if radius is given. Suppose I have given you radius as 5. Okay? I have given you radius as 5. And I am asking you to calculate the area of circle. So how will you do that? This thing is already covered in the last 3 lectures. Okay. So can you recall what is the area of a circle? What is the formula for calculating area of a circle? It's pi into radius into radius. Now can you calculate? Okay. Solve with me in on your copy and with a pen. Suppose I have given you radius equals to 5. Then area will be what is the value of pi? It's 3.14. It's 3.14. Okay. Or you may use 22 by 7. To get the exact area, we will use a double data type here. Why? Because double data type will give you answer in decimal format. And here we are using decimal 3.14. 3.14 into radius. Let us try printing this and see what we will get. This is the first question. Cool. We got 78.5 as our answer, right? Okay, suppose if I would have used integer data type, then it would have given you 78 only. Yes, it is giving you 78. But we want the exact area, so we will be storing the answer in double data type format, right? This is the first question, first practice question. I hope this is clear to all of you, right? Okay, let us do few more questions. So the question 2 is check whether a number is divisible by any other given number or not. So you have to check whether some given number is divisible by some given number or not. Okay? Yes. So how will you check? Suppose I have given you int num is equal to 133. So you have to check. Suppose another number I have given you is 5. Number 1 is 133. Number 2 is 5. I am asking you to check if 133 is divisible by 5 or not. So how will you check? That boolean thing, right? Okay. If num1 modulo num2 equals to 0. What does this modulo do? It tells you the remainder. If 5 is completely divisible by 133, it will give it remainder as 0. Otherwise, it will give remainder greater than 0. So, we will print true. Yes, it is divisible. Right? It is divisible. Else, we will print false. It means 133 is not divisible by 5. Let us check this. Yeah, it is giving us false because when we divide this 133 by 5, it will give you, I think, 25. Yeah, it will give you remainder 3 because 130 is divisible by 5 but not 133. So somewhere it will be leaving remainder as 3, which is not 0. Okay, so this is the second question. Try yourself checking divide any number by any number, right? Okay. So the next question that I have for you is question number 3. It says calculate the ith power of a number. Calculate the ith power of a number. So how will you do this? Suppose if I am giving you int I, that is the ith power, as 5, and suppose I am giving you num as 14, let's say 14, right? So how will you check, like how will you calculate the fifth power of 14? Like, do you multiply 14 into 14 into 14 into 14 into 14? Will you multiply 14 in 5 times? No. I taught you include a header file. Include math.h. Okay. When it is iostream.h. Iostream. When it is iostream, you have to include this header file. Okay. So how will you do that? Pow num comma I. Whose power you want to calculate and which power you want to calculate, right? Let us see what it will give us as an answer. Oh, it is giving us 537824. Great. Yeah, great. Okay. Okay. So if you don't want to include this header file, let me comment it off. I already told you how to comment out a single line. Include bits std header file. It will provide you multiple functionalities. Okay, no need to include this math to rich. It will still work. Yeah, it is giving you the same answer as 537824. Okay, this was the third question. That is based on your knowledge from lectures 1, 2, and 3. Next question is question 4. Question 4. So in this question, I'll give you four different binary representations. Yes, I repeat, binary representations. You have to calculate, you have to make it decimal representation. It means you have to convert binary representations into decimal representations, right? Okay. Suppose I am giving you first representation of binary is 1010. So how will you solve this? How will you solve this first binary representation and convert it into decimal? Okay. So what you will do is, as I already taught you, let me maintain some space. So what you will do is, you will multiply this rightmost 0 with 2 to the power 0, right? And this one by 2 to the power 1. And this by 2 to the power 2. And this by 2 to the power 3. So what will you get? Adding all these, what will you get? Okay, it shifted. No worries. Yeah, it shifted. Sorry for the inconvenience. Yeah. Okay, no issues. We can still walk. So 0 into 2 to the power 0 is 0 only. Plus 2 to the power 1 into 1 is 2. Plus, I am calculating from backwards, right? Here, like this. Okay. 2 to the power 2 is 4. And into 0 is 0. Yes. 2 to the power 3 is 8. 8 into 1 is 8. It means it is giving you 10 as an answer. So, binary representation is 1010, decimal representation is 10. Next is 1 1, 1, 1. So how will you calculate for this? 2 to the power 0 into rightmost one is 1, right? 2 to the power 1 into rightmost one is 2, right? 2 to the power 2 into this one that I'm pointing my cursor to is 4, right? 2 to the power 2 into 2 to the power 3, sorry, into this one is 8. So after adding, you will get something like 15. 1 plus 2 is 3, 3 plus 4 is 7, and then 7 plus 8 is 15. So this is how you calculate decimal representation from the given binary representation. I think this is enough for you to get an idea how to calculate, how to convert binary representations into decimal representations, right? Okay. Let us move to the fifth question, fifth practice question. Fifth practice question. Okay. Convert convert decimal representations into binary representations. Binary representations. How to convert decimal representation into binary. Although this I have not taught in the lecture, this will be a new concept for you, but I'll make sure that you will get it very nicely, right? Okay. Suppose I'm giving you 5. Okay, suppose I'm giving you 5. How will you make it in binary representation? So you will take a LCM. Take a LCM with 5. Okay. So what you will get? 2 to the 4. So write a 4 here, like 2 to the 4. Write a 2 here, and the carry remains is 1, because 5 minus 4 is your 5 minus 4 is your what? 5 minus 4 is your 1. So 1 remainder, right? Okay. In the next line, you have a 2. You will write a 2 here. 2 1 the 2. So what you will do? It will multiply 2 1 the 2. This 2 will be multiplied with this 1 to give this 2, and remainder will be 0, right? Again, this 2 will be having a remainder call with this 1, and what it will give you? It will not get multiplied by this. Why? Because 2 is greater than your 1. So write 1 as it is. Write 0 because it is not multiplied. And what will be the remainder? 1. So this is how I just simply took the LCM of 5 with 2. Why 5? Because it is the decimal representation. Why 2? Because you have to convert it into the binary format. Binary means 2, right? Just take a LCM with 5 and you will form some series of remainders. Like I got 101. Now the main things comes into picture. Start reading these remainders in the reverse direction. Start reading these remainders in the reverse direction. Start reading from below. Read this one, you will write a 1, right? Read this 0, you will get a 0. Now read this topmost one, you will get a 1. So here comes your binary representation. This is the binary representation of your 5. I will show you this thing with another example to make you more familiar. Suppose you have a 23 number, right? You have 23 and start taking LCM of this 23 with 2. Can you tell what you will get? What you will get? 2 11 the 22. It means there is a remainder left, that is 1. Again start multiplying this 11 by 2. Start dividing. 2 into what gives you 11? 2 into 5 gives you 10. Again the one remainder left, right? Okay. Next line. Divide 5 by 2. It will be like 2 to the 4 and it will give you one remainder again, right? Okay. Now divide 2 by 2. How it will divide? By 1. Remainder left is 0, right? Okay. Now again, divide 1 by 2. It will not get divided. So you will write a 0. And remainder left is 1, right? So try it on your copy and pen. I just have taken the LCM of this 23 with this 2, right? And I got this remainder sequence, right? So as I told you, start reading this sequence from bottom to top. This one will give you 1. This is 0. This is 1. This is again 1. This is again 1, right? So this is your binary representation for the decimal value 23. Just take the LCM with 2 and start reading the remainders from bottom to top. I hope you all are clear with this calculation. Okay, let's proceed to the next question that I have decided for you. Okay, so the next question is, check which is greater. Check which is greater. Okay, check which is greater. Suppose I have given you a character ch is equal to small a, and another I have given you ch1 is equal to capital A. If ch is greater than equal to ch1, you will print a true, right? Else you will print a false. What do you think? What will be the answer? Is small a equal to or greater than? Okay, I'll not put a equal to. You know that it is case sensitive, so it will not impact much. So this is a twist part. Like, do you think like a is greater? Let us check the answer and then we will discuss. As you can see, it is giving you a true. Now you will be like, ma'am, how it is possible? Like small a is small, it is a small a, it is a capital A, then this should be greater. Why the small a is greater? Because it is small a. Okay, I told you that characters are not directly compared. Characters are not directly compared. Okay, the characters are not directly compared. They're what? They're what? Their sky values are compared. Their sky values are compared. That's why I told you to go to Google and search about sky values. Sky value of small a is 97. I repeat, 97, right? Okay. And a sky value of capital A is 65. Now are you clear like why small a is greater than this character 1, that is capital A? Because its sky value is greater. Although we used to call it as small a or capital A like this, but its sky value of small a is greater. That's why it is greater. I hope you all are clear with this question. You can check out other comparisons also. Try comparing 10 with 2, try comparing 5 with 4, try comparing 1000 with 100. You can make any kind of comparisons. Okay? Okay. Question 7 that I have for you is, question 7, like whatever values I am teaching you, with whatever values I am taking examples, try different values with yourself. Like when you will try it on copy and pen, try with different examples. Otherwise, it will be like ratification. Okay, you will try to match with my answers, right? Try it on your own, right? Okay, now let's move on to the seventh questions. Calculate constant expressions. Calculate constant expression. And expression is 2 into 3 by 4. What do you think? What it will give? Let us check. Okay, it is giving you 1. And if I do a modulo, it will give you 2 because the remainder is 2. 6 modulo 4 is 2. And 6 divided by 4 is 1. 4 1 the 4 and 2 remainder left, right? This is a simple question that I wanted to tell you. Like, you can try other constant expressions as well, complex expressions as well. Okay. So the last question 8. So the last question 8 for this video is, okay, this will be a very much fun. It is based on, let me tell you, it is based on compound expressions. It is based on compound expressions, right? Okay. Suppose I have given you num as 100 and I have asked you to first perform first multiply equal to operators on it. Multiply equals to. Second, I asked you to perform, I think I asked you to perform, yes, plus equals to on it. Third, performs divide equal to on this. Fourth, try to perform minus equal to on this. Now you will be asking, like, by what? Perform by what? Suppose I am giving you the number as 5. Num2 is equal to 5. Try performing the operations, respective operations in the same manner. Okay, so first is 100 multiply equals to 500. It means num1 multiply equals to 5. How it will be, 5 not num2, because it has a valid variable name. How it will be expanded? Num1 is equal to num1 into num2. So what it will give? Let us check. 100 into 5 is 500. It will give you 500 because num1 equals to 100 into 5 equals to 500. Now you will say, like, 100 is equal to 100 into 500. Here on the left side you are representing it by num1, and here you are giving the value, because always the value comes to the right hand side of the equal to sign, right? Equal to sign. And num1 variable name comes on the left hand side. I used to think same, like, why we are not doing 100 is equal to 100 into 5. It is not a valid thing. You have to store this value 500 into something. Now that's why num1, like, variable name should be written on the left hand side of this equal to, and then value should be written on the right hand side, right? That's why we are having num1 here and value of num1 here. So it is giving us 500. What is the next expression? Plus equals to. It means we have to do num1 plus equals to num2. How we will be expanding it? Num1 equal to num1 plus 5, right? So what it will give you? What it will give you is equal to, it will give you something like that. It will give you 500 plus 5. This is 505, right? 505. Now the third expression is divide by 5. So directly we will do 505 divide by 5. What you will get? 101. Directly I have written because I have already told you the formula. Okay. Now 101 minus equals to 5. What it will give you? 96. Yeah, the final answer for this expression after passing from lots of compound expression is 96. Yeah. So these were some of the questions that were based on the knowledge gained from lectures 1, 2 and 3. I would suggest you to practice some more questions similar way, like make some more concepts clear by practicing some of the questions, these kind of questions. Okay, in the next video we will be covering lots and lots of concepts, and I will be conducting a practice session for those concepts also, so that those concepts will be covered practically. For these lectures, these questions were enough, right? Okay. So I hope students you all like the video and gain some knowledge out of it. Thank you so much for your time. Thank you. Bye bye.